Mercury is the fastest planet in our solar system. It races around the Sun every 88 Earth days, which means a year on Mercury is shorter than a day. That's right, you could age faster on Mercury by taking a trip around the Sun. The diameter of Mercury is approximately 4,879 kilometers. This makes it the smallest planet in our solar system, even smaller than some of the moons orbiting other planets like Jupiter, Moon Ganymede, and Saturn Moon Titan. The distance between Mercury and Earth is not constant because Mercury has an elliptical orbit around the Sun. This means its distance varies throughout the year. When Mercury is on one side of the Sun from Earth, called inferior conjunction, it can get as close as 38.2 million kilometers from us. On the other hand, when Mercury is on the far side of the Sun from Earth, called superior conjunction, it can be as far away as 227.9 million kilometers. Despite the variation, the average distance between Mercury and Earth is about 57.9 million kilometers. Mercury might seem like a small rocky world, but beneath its crater surface lies a surprisingly large and mysterious core. Mercury is a dense little planet. In fact, about 70% of its mass is made of a giant iron core. That's a much higher percentage than Earth, where the core only makes up about 35% of its mass. A mind-bending fact about Mercury: a day on this scorching planet is actually longer than a year. How is that even possible? Unlike Earth, which spins on its axis every 24 hours, giving us our day-night cycle, Mercury rotates incredibly slowly. It takes a whopping 58 Earth days for Mercury to complete a single rotation on its axis. That's more than 2 months. Tidal locking is a fascinating phenomenon that occurs when a celestial body, like a moon, is always forced to show the same side to the body it's orbiting, like a planet. It's like a slow dance where one partner, the moon, gets gradually pulled into a fixed position by other gravity, the planet. The most famous example of tidal locking is our moon. One side always faces Earth while the far side remains mostly unseen from here. Mercury's revolution around the Sun is much faster than its rotation. It takes Mercury only 88 Earth days to complete an orbit around the Sun. The primary reason for Mercury's extreme temperature is its proximity to the Sun. At an average distance of about 58 million kilometers, Mercury receives 10 times more sunlight than Earth. Mercury has almost no atmosphere. This means there is nothing to protect it from the constant bombardment of macrometeorites and asteroids, leaving the surface cratered and scarred. Unlike Earth, which has a protective atmosphere that traps heat, Mercury has almost no atmosphere. This thin atmosphere is no match for the Sun's relentless rays. The heat from the Sun is absorbed directly by the surface, with almost nothing to stop it from radiating back out at night. The lack of atmosphere also leads to another dramatic effect: wild swing in temperature between the day and night sides. The day side of Mercury can reach scorching temperature exceeding 430 Celsius, hot enough to melt tin and lead. However, the night side plunges into darkness, with temperature dropping as low as minus 180 degrees Celsius, cooler than the coldest place on Earth. You might be wondering why the scorching dayside heat doesn't create a runaway greenhouse effect on Mercury. The answer lies in the thin atmosphere. There are not enough molecules to trap the heat effectively, allowing it to escape back into space during the long night because of the extreme temperature on Mercury. It's not a place humans could ever live permanently. However, several spacecraft have visited Mercury, including NASA Messenger probe, which spent years mapping the planet's surface. Mercury might seem like a rocky, airless world, but its surface holds a fascinating secret. It's wrinkled. These wrinkles, called scarp, unlike the smooth, cratered surface of some moons or asteroids, Mercury's surface is covered in a network of ridges and valleys, resembling a wrinkled apple. These wrinkles or scarps can stretch for hundreds of kilometers and reach up to 3 kilometers high. Scientists believe these wrinkles are the result of Mercury shrinking over billions of years. Early in its history, Mercury was much hotter and larger. As it cooled, the planet's interior contracted. The solid outer shell, however, could not shrink at the same pace, creating a wrinkling effect like squeezing a deflecting rubber ball with a slightly too big stiff outer layer. The scarps are generally oriented toward the Sun, suggesting the formed as the planet contracted in that direction. Mercury is denser than any other planet besides Earth, possibly due to the iron-rich core taking up a larger proportion of the shrinking planet. Mercury is constantly shrinking. The tiny planet cools and contracts slightly with each passing orbit around the Sun. This shrinking process causes wrinkly ridges on the surface, which look a bit like a prawn. We have explored Mercury's scorching temperature, wrinkled surface, and speedy orbit. But here is another curiosity. It has a magnetic field, but unlike Earth, it's very strange. Unlike Earth's strong global magnetic field, Mercury's magnetic field is much weaker, about 1% of Earth's strength. It's also what scientists call an open magnetic field, meaning the field lines don't form a closed loop around the planet like Earth. Instead, they stretch out into space somewhat like a weak, open umbrella. Mercury has a very weak magnetic field. This is because it has a slow rotation and a very thin atmosphere. The weak magnetic field means Mercury is constantly bombarded by the solar wind, which can even steal particles from its surface. Since Mercury rotates so slowly, a sunrise or sunset on this planet lasts for weeks, not minutes like on Earth. Imagine watching the sunrise or sunset in slow motion for days at a time. Unlike most planets that orbit the Sun in a near circular path, Mercury's orbit is quite elliptical, meaning it's more oval shaped. This contributes to extreme temperature variation on the planet's surface. Did you know Mercury doesn't have any moons? It's the only planet in our solar system that travels solo.